thank you, Building Transformation, for putting together this project story series. We're happy, very glad to be here sharing about some of our processes and specifically how those processes interact with specific projects in the GTA region, such as the U of T student residence. So I'm here today with my colleague, uh, very smart person, but also a great guy, Sina Karimi, who is a R&D specialist in construction robotics. So Sina, if you wanna maybe give some words about yourself.
Thank you, Robert. I'm Sina, R&D specialist, focused on robotics and reality capture applications in Pomerleau. We are excited to be presenting our project story with you today, and hope you enjoy it.
Awesome. Thank you, Sina. So let's get into it. Let's use the best of the next hour to talk about how we share a vision. I think is shared with Building Transformation and with many of the people who are attending this session. And that vision is to shape the future of the construction industry. Pomerleau has been working very hard to lead some of the innovation that is now shared and used as a common practice. And we're happy to do that in collaboration with our partners, with the Academy. And it's definitely not an effort that is only done in-house, it's shared and it's a collaborative effort. So I think we are on the same page. We want to talk about some of those lessons learned and processes that we now have put in place for two specific goals. One is digital progress tracking. I'm going to be presenting this part, talking about the framework, the project feedback, and especially what are some of the ROIs that this specific process brings to our projects. And then I'll pass it on to Sina with his experience and his approach to the robotics reality capture. Um, so just to put things in context, I'm going to do a brief introduction about Pomerleau. As Tom mentioned, we are a general contractor, one of the largest general contractor in Canada. And we not only create infrastructure and build projects, we are also here to build communities. And the communities that we build is not only around the projects, it's also around the innovation that happens in our projects. And we're aiming in every project to leave a positive impact and to have really exceed the expectations in every project that we approach. So a little bit of Pomerleau and evolution throughout the years. We have been around for 60 years, and it started and still is a family business. It has that family culture, not only because it's still led by Francis and Pierre Pomerleau. It's because everybody who is in this team really feels that you have that connection, that you can talk about any issues and you can bring your ideas to the table. So one of those ideas that were brought to the table happened in 2012 when Pomerleau decided to have BIM as a practice, a structured practice in our project. So that was already 10 years ago. And if you want some maybe pop culture references for what happened in 2012, so that was a year when we thought that the world was going to end based on the Mayan calendar forecast. And it's also a year when the first Avengers movie was launched. And so a lot of things have happened in the last 10 years, including obviously the COVID pandemic. But within those years, specifically in 2020, Pomerleau was also able to be the first company in the world to have a Boston Dynamics robot on a construction site doing operations and bringing value to our team. So Sina will explain a little bit about that. But it's also worth to mention that COVID-19 helped and really was a key factor to start thinking about how we can accelerate our innovation. And that's why in 2021, we launched the Acceleration Lab within Pomerleau. It's a team, it's a unit that is dedicated to really put all those new ideas and those new technologies in place and have a structure that will be ready for the next phase. So I'll mention a little bit how that works. But again, just to give you some metrics, we have around 200 active sites across Canada, 4,000 employees, and around 20,000 people working on our site. So that's why it is that important to have a positive impact and to build uh, those teams as we approach projects. So presence across Canada, as you can see, offices not only in Quebec but also in Ontario and BC. Our expertise is, as you know, buildings, also civil and infrastructure, but it is also, and we're proud about our expertise in construction innovation. This happens by basically organizing 8 different research and development axes. They go from artificial intelligence to Internet of Things, planning, reality capture, prefabrication, obviously robotics, that is also part of the reality capture axis. And it has been discussed in one of these series before. Canby is doing building transformations, is doing a great job talking about the value of digital twins, and we have a dedicated axis on that end too. Now, this innovation and all these different topics, they have a really unique approach. And if we consider the size of the innovation team, we're talking about more than 100 people dedicated to do it, to do R&D, beam implementation, framework analysis. But the implementation is not close and is not limited to those people. The innovation happens hand by hand with the operation teams. And the picture that you see there is an example of just how diverse and how open our innovation is. Maybe 30% of the people who are there are actually from the innovation team, but the rest are people who have led innovation projects from the operation side, from the scheduling side, and that's really the key to make the operation feel needs and feel need for our projects. So we divide now our framework in 2 parts. The R&D, it's led by the new acceleration lab, and then we have a team that is focused on the deployment. And this team, we call it the Foundation for Operational Excellence. And this is where we really structure how things are going to be applied on projects and how we can scale those benefits. So I'm doing this introduction to get to our main 2 topics today. You will see that they use different kind of processes. Some of them are more mature technologies, like maybe platforms that we have available in the market, platforms for beam collaboration, platform for quantity takeoffs. But we also have some other technologies that are more emerging and that they require that level of in-house analysis and in-house opportunity analysis. So with that, I want to talk about digital progress tracking and digital progress tracking applied to the UTSC project. So what are we looking to digitize the way we are getting productivity rates, for example? All this is with the vision of having and enable a new capability in our teams, and that capability is to have data-driven decision making in our operations. So I want to share the origins because we're talking about stories, so every story has an origin. And it's no different from what I mentioned before. The origin of digital progress tracking as an active and actual solution right now started in collaboration from operations and innovation teams. So we have an initiative sponsor for this um, research and development. That was Nuno da Silva, project director for the CBO and for the Toronto team, who brought a lot of expertise to the table and joined forces with the VDC and innovation team to really start developing a solution that will fit the project needs. So it started as a conversation around this topic, sort of like a Pomerleau in-house think tank, but then it was captured and it followed the process that we described before. Now, what was the issue with the traditional way of doing progress productivity and progress tracking? Well, as you see it there on the screen, we have probably 5 steps on a typical productivity tracking workflow. The first step is about extracting the quantities from either a BIM model, if that's available, or just by using typical estimation tools like CosX to get that database of quantities and have them shareable with the other team members. The second part is actually marking up some of the drawings and defining some of the areas that will be related to this quantity. So one example is maybe the uh, concrete pouring sequence, where I'm sure if you've been involved in any concrete project, you're seeing these PDFs, these 2D documents that have a lot of markups, and it's pretty a common practice in construction these days. So after that, probably the project manager or project lead start putting together these different databases in what has been a typical solution in Excel, try to bring some information from the schedule and also link the breakdown to the quantities to the dates. And then what happens when we have a monthly report or we want to share this with maybe clients or subcontractors? Typically, you go to an office tool like Word or PowerPoint, and you create a report that then is stored in your CDE, could be Procore, could be Box. So that's what happens right now. Now, what are the limitations of this workflow? Obviously, you have to update this report, and then you identify right away that there are data silos. So the information that you extracted is not longer compatible with maybe the new way that the team is looking to organize the concrete pouring sequence. Then you also have a disconnection with that master Excel master database, and the reporting part is just a nightmare to really update, and not only spend a long time to do that, but also to reduce maybe the quality of that process over time. Now, is there a better way? That's the question here. That was the question that we put in the table when we started talking about this. So, is there a way to really reduce the number of platforms, reduce those silos of content and unconnected data, and have just one database that merge all this information and one reporting tool that is not only able to report, but is also able to use some analytics and smart data connections. So we approach this by exploring some of the mature technologies that are available in the market. One of them, it's Assemble, and the other one is Power BI. So with Assemble, we were able to connect the data that is coming from the BIM models, from P6, and even some data from Procore, like crew sizes and crew logs. So that data is now centralized, is in one place, and the reporting part is just a matter of extracting and selecting different data sets and organizing in a way that enables that data-driven decision making. So it's the path that we follow to start really deploying this initiative. And in terms of the deployment, we'll refer now about the project that we're going to present today. We actually use this strategy in 4 projects in parallel as an initial pilot phase. And the reason is that we wanted to compare maybe some similarities, but also differences between these projects. So the University of Toronto Student Residence is a design build project. It's also a passive house project, which will be one of the most energy efficient buildings in Canada. It is a project that it's around 25,000 square meters of surface area, and it's going to host 746 units for the students of the University of Toronto Scarborough campus. So, with a project of this nature, we obviously had many opportunities to explore how we can really provide this one platform and analytics tools to enable decision making and to really open new possibilities to the management of the project. So I'm gonna describe right now three specific uses of the DPT, digital progress tracking process. One is to get productivity tracking. The second one is to understand the implications and the affectations of the manpower. And the third one is about how we can even explore not only the productivity size in terms of time, but also in terms of cost and conversion to unit prices. So for the first part, productivity tracking, we had now a solution for taking a BIM model that is meant for design purposes, that has a breakdown that is based on elements and families and typical Revit structure. And we're now being able to add and condition this model with information about the master format, division code, and the P6 activity IDs that are related to the elements in the model. So that is the first step. That is the key step. So we can start mapping the work breakdown system, which is different in design to construction. And the second part of this equation is to have also the on-site installation status inputs from the team members, and these inputs were mainly the installation uh, status and the completion date. So that was the main step. That was the first approach. So we had now models that are split and they have master format codes, but we also wanted to understand the implications, as I mentioned before, about the crew sizes. So with Power BI, we can also start linking and reading information that it's available, that we have available in through Procore, and by having the number of hours that each subcontractor is registering in our projects, now we can understand the curves of crew sizes, when that curve is increasing, when that curve is decreasing, because they're almost done with their scope of work. And with the two, we can really enable a new potential for project managers and directors to really understand the relationship between productivity and uh, manpower. So what you see there, it's one of the many different graphs and analysis that we started to explore and extract from linking the models for this project with the data that we wanted to add to the models. So here you can see two curves. One is about the productivity and one is about the crew size analysis. So as you can see, they have a correlation, and this is not historical data that you can use to, confirm and make it obvious that the crew size affects the productivity. It's also a solution that can let you identify early flags and early concerns and problems. And this is exactly what happened in this project. I have many quotes and feedback from the actual project managers and directors, but just to read some of them. So by having these curves, we're able to increase and decrease the crew as required to ensure that we are still maintaining a schedule during the same month that we're working in. So right now, every project that has this process in place can make those decisions and identify those early flags. You don't have to wait until the productivity is going too low to call the subcontractor and say, "Hey, we need to increase the crew size. We need to work on weekends." You can have now this big picture and comprehensive picture of what's happening in the projects by merging the bean data and the progress tracking data. Another example here of the value of these two projects. Um, we have, in this case, Farmwork. I'm tracking the production of the Farmwork. So now we can see what is the average and how that average is also affected by um, productivity in terms of hours per square meter. So this is also a correlation, but in this case, it's opposite. So the higher the number, that means that there is more hours spent completing the same scope of work. And as we went through the initial levels of the building, like the foundations, we're starting to reduce the number. We started to be more efficient, and we were able to now not only get these records for this project, but now we start thinking about database of projects, how we can now use this productivity, sorry, for similar projects. So um, hopefully it is a clear example. This one, it's also another example, another approach of how we can use the data from the models to compare plan productivities from a baseline schedule, uh, updated schedule, and the actual productivity. So the three curves that you see there, the gray one is um, for the plan. So the baseline schedule had some dates, have some deadlines to complete certain quantities of the structural concrete. The blue cyan curve shows the actual, and because there were changes and COVID affectations for this project, there was a revised schedule that now you can compare with the actuals. So again, instead of trying to gather data from uh, markups, PDF, or Excel table, now you have the data link and giving you the information that you need to really ensure that the project is on track and that the project is on schedule. Now, different exploration, and this is more related to the unit conversion to unit prices. Now we have productivities that are coming from the sites, are actual productivities. How we can use this to understand the overall unit cost for this scope of work. So this is done, and this was done with the experience and the expertise of our project directors, just assigning and trying to ballpark some percentage of labor and material and equipment. So in a typical scope of work, that could be maybe 50-50, but it really depends on the scope of work. So for example, farm work, the percentage of labor versus equipment and material, it's around 40%. So we can use the actual productivity to really, estimate and compare unit costs to the base estimates and the base budget for the project. So this again is enabling data-driven decision making. It's giving you information early in the project instead of having to wait and increase the cost of adjusting and making a decision. Another example here, it's a production tracking for the mensury, where we also divided different milestones, like the installation, the drywall, and just by linking that and isolating the model in different views, we can also have some like planning methodology to make sure that we understand the progress on different areas of the building. Lastly, on this set of examples, we have another kind of graph that shows how deviations in one scope of work affect other ones, sort of like understanding the critical path. And this is just a reference example, but we can see how there is a sort of like cascade effect on a set of scope of works in the project. So we did all this to really put this initiative, put this idea in place. And out of that, we extracted some lessons learned and requirements to make sure that the digital progress tracking processes works efficiently. So number one, we need to have B models, but we need to have B models that have the LOD agreed ahead of the project, have those discussions early enough to really understand the level of detail that we need to make this happen. We need to collaborate with the project to define the work breakdown system and the same structure with the schedule and in this case the P6 setup. We also need to have Revit elements that can be broken down in parts. So that is a work that it happens between the design and the construction teams. So we can then map the elements to the specific scope of work. We need to have that manpower entry in the construction management platform of the project. We need to get those daily or weekly on-site inputs from somebody in the team. And finally, we need to coordinate the data reporting needs. As you saw there are many different ways of presenting this data, and it has to be based on the project needs. And finally, this is, I would think, one of the most important points is having a really data sharing culture in our project, so people are sharing information at all times. So other implications of this approach is changing and adding some specifics to the BIM execution plans. Obviously, the use of quantity takeoffs has been there for a long time, but putting that in place is actually need to have a very specific framework, as we saw before. So finally, in terms of ROIs, we have some tangible ROIs, like the number of platforms that now we have integrated. We're targeting for have one or two platforms at the most. Right now, it's one platform that reads everything, and then the reporting tool. In terms of time to create these reports, we have been able to reduce this more than half. So imagine that something that takes 5 days on a weekly basis is now taking 2 days, and you multiply that for the number of weeks in the project, that is saving resources to focus on more important tasks. We also have some capabilities to transfer templates between projects, so it's not something that you need to start from scratch every time. Now you can share these templates both in Ensemble and Power BI for different projects. And in terms of intangible, I think, and I hope it's clear that we are basically enabling capabilities for our teams, and that right now our teams are salesmen of this process, and they have that vision now that all the data that is tracked in one project is not only going to benefit that project, it's going to help to estimate and plan projects way more efficiently and with a better knowledge in the future. So that is one intangible KPI that we received some feedback on. So for the next part and the next steps of this process, I'm going to pass it to Sina, where he's going to explain a little bit more of the emerging technologies for reality capture and how this can benefit our projects as well. So back to you, Sina.
Thank you, Robert. Thank you for sharing this project story. Now that we have shared our story for digitally on digitally how to progress how to track the progress of a project. Now we are focusing on bringing to the next level, which is the robotic reality capture. And for that, I'd like to start with a broad and brief overview of the reality captures opportunity that we have in the construction industry. Our R&D team is focused to use automation with robotics, trying to help with that problem to effectively monitor and manage job sites. That level of comprehensive site visibility requires unprecedented amount of reality capture and site data. As Robert said, we are working on DPT, so we require data from the site. And this reality could be captured in different ways, which requires various sensors. And in addition, the frequency of captures are important as the visibility of site requires consistent reality capture. So I'd like to start with a question before going any deeper into how we use the robotics in Pomerleau. So why can it be useful to use robots for reality capture on a construction site? Basically, the work is dull and difficult for a human. For example, being able to take a photo or a laser scan at the same location at the same time of day with the same lighting condition day after day and after day is an extremely difficult job for a human to do. The people assigned to that level of reality capture are typically going to bring more value to the project by working on other things. With robots, we increase the amount and the frequency of data capture while decreasing the labor hours, keeping everybody focused on higher value tasks on the job. And when it comes to fixed sensor systems like cameras or any other types of sensors of that nature, there is a huge risk there. What if something gets in a way? And also, this needs to be fixed. This amount of reality capture needs many fixed sensor to cover the job site, while a few mobile sensor moving can achieve the same task. So the mobile sensors are really the key to getting the job site data needed effectively. And autonomous robots automate this process for us with high repeatability. Then we are able to increase the frequency of reality capture, meaning less change from capture to capture. And with less change, our downstream analysis applications, such as machine learning and computer vision tools, used for the progress monitoring can work more effectively and can understand the change detection, can understand the changes better. So that gives an answer to the need of some of requirements for data-driven decision making. So when it comes to use of robots on job sites, the first thing is what is the right tool and how it can generate more value. So a dynamic platform is always needed, which can capture accurate data. So for a construction project, since those projects are exclusive in nature, we should consider which tool fits the job. So the type of project is also important. Also, the current workflow works perfectly fine, and we need to see how we can fit and generate more value with robotics. The tool we use should be able to repeat the same task as many times as we desire. Also, the tool needs to have enough autonomy duration to capture reality, and it needs to be compatible to use various sensors. So let's go through some of the application that we use with the autonomous reality capture and the ones that we look ahead. First, the job site monitoring that we use to capture 360 photos, usually once a week, and it also depends on the type of job. And we take these photos frequently over time to understand the progress and deal with disputes. On the other hand, you can see how we use Spot to capture and upload 360 images. Uh, we want to record the path for the robot to understand where we want the captures happen, and Spot autonomously captures once or twice a week. These photos are marked on the plan so the project team knows where those 360 photos are taken. And when we run Spot day after day and after day, the robot keeps capturing and uploading the new 360 images. That enables our project team to understand the progress and monitor the site. Also, we have many projects working and coordinating in 3D in BIM. The project team wants to be able to compare as built to the model. There are a few ways to do that, and there are very good software tools out there to do it for you. But before that, you need the data to be captured accurately. And as you can see, this is the point cloud that's generated by Leica RTC 360 with Spot. We've made this integration to use a highly accurate laser scanner with Spot, and in this direction, we also superimpose the laser scan onto the model to get the deviation or any potential conflicts we want to catch of the point cloud against the model. We've been able to build a process where we collect point cloud, import it into our software, and visualize the deviation from model. Then we can see if an element is installed, is it installed in the right location, and are there any conflicts? This is critical as it allows our projects to quantify the work and start to come up with a metric by which all stakeholders can agree upon in terms of indicating completion. And I cannot emphasize enough that first and foremost, the robot gives an opportunity to remove workers from potentially hazardous situations. Think of confined spaces, but also think of spaces where it is easy to trip. Again, think of pre-port decking where some kind of injuries could happen. We don't risk a person to do that level of reality capture in that kind of terrain. On the right, we have Spot in a confined space where potential hazardous or dangerous situation could happen. We use Spot lights on the camera to identify the potential dangers from that reality capture data and resolve them quickly so that they don't continue to be in danger. And also, autonomous reality capture presents opportunity for everyone involved in the project. So nearly real-time data capture impacts nearly every aspect of the project process, including estimating, bidding, construction, and completing, and also verifying the project. Reduces fees for all the site investigation that have to be done to verify the site conditions. And these are the opportunities for our clients. We can provide them with accurate as-builts and also enhanced digital models. Then the effectiveness of a reality capture is for our clients, of course, is for them to be cost effective and also to go into direction to have a digital twin of the real asset. So now here we are looking at 5 major steps of reality capture, which are highly labor intensive, and we aim to add automation not only to each step, but also during transition from one step to the other. When we use robots for data collection, it's not about capturing the data. It is also about the migration and how we use the data as well. We are looking at a typical data collection workflow from planning to action. And our robots help us in the first 3 steps where we want to plan the mission for the robot, capture the data, and transfer them to our experts. In this case, we are also able to reduce the commute hours to generate higher efficiency in our processes. And the first 3 steps are our robotic reality capture technology, and the last two steps that they take place in our software ecosystem. So first we have the path planning, which we need to indicate the robot where to go and what action to execute. And this can be done in 2 ways, offsite and onsite. On-site mission planning uses Boston Dynamics native AutoWalk feature to record the path through the environment, record the series of actions, save it as a mission file, and then repeatedly send that to the robot through the site. You can see an example on the lower right with the Boston Dynamics tablet. Also on the upper right, we are able to do offsite mission planning, where if we have a previously taken point cloud or a BIM or a CAD model, to import it into our software ecosystem, pre-plan the path for the robot to to direct him for the reality capture, and then when the robot is done, it's gonna push the data to the cloud. So the robot is equipped with smart perception of the environment and to understand whether there is an obstacle, choose a route around it, and come back to the initial path. Spot and its sensors capture reality, various data and realities such as laser scans, 360 images, thermal images, etc. It really based on the application that we want to focus on and what we want to do with the data. As you see here, Spot is an autonomous mission where it is capturing laser scan and 360 images simultaneously. By having Spot, we can capture different kinds of data all at the same time, so we increase efficiency in terms of automation. We believe that autonomous reality capture needs to be complemented with the migration of data for downstream analysis. And captured data would not do any good unless the stakeholders get that data. So we use the docking station, as you can see in the slides, to charge the robot and push the captured data to the cloud simultaneously. And the docking station is equipped with gigabits Ethernet port that facilitates data upload to the cloud. And oftentimes, the people who are running the analysis on the data are remote. They are offsite. They are not part of the reality capture team on site. So transferring the data to a remote location increases the reality capture efficiency. As the robot is recharging, it sends the large files of data, such as 360 images and laser scan point clouds, to the cloud. And it is all done as part of the autonomous mission. There is no human interruption. To the person on the other side, they might not even know that there is a robot on the job site which takes care of the reality capture and sending the data to them. All they know is that they are getting the reality capture regularly in near time. It means that they will be able to generate more value for the project. And also, since we capture the data, we also would like to analyze the data to some level. And as you can see, you're seeing an example of capture data with Spot, and then we wanted to get deviation from BIM. And it is also all done as part of an autonomous process. So when we get the data from Spot, we put it into our software ecosystem, and the algorithms that we use are able to highlight the deviation from BIM. And in this case, we are helping our project team to put their time and their energy to resolving the issues. And with the robotic reality capture, we are helping our project team to find the issues so that they can resolve them quickly. So before we go any further about that, how we actually use Spot, I want to get your attention on how we can configure Spot with different payloads on it to capture different types of data. So Spot automates our on-site data capture, and by virtue of that level of repeatability, we are able to increase the frequency of data capture. As you can see, we have 360 camera payload on the Spot. We can have different types of laser scans. As you can see on the lower right, Spot is equipped with RTC 360, which is a highly accurate laser scanner for the application that we need higher accuracy. And if you wanted to capture the data quickly, and still we want to capture the accurate data, we can use other types of payloads. As you can see, we use Leica BLK ARC on the Spot to capture reality in nearly real time. So now let's have a look at how actually Spot captures data on our job site. So this is one of our projects that we automate the laser scanning with Spot, and this project was also submitted to previously known CAN-BIM and now building transformation. And We are excited that we won an award for this application. As you can see, Spot is an autonomous mission. There is no human interruption, and we are having Spot equipped with different sensors, RGBD cameras to capture images, 3D laser scan, 360 images. And as you can see, we want Spot to go on a specific location, stop there, and capture the data for us. For this specific application, we mark the point, we mark the location with the QR code. So Spot is equipped with uh, AI algorithms to detect the barcode, stabilizes itself so that we have less noise in our point clouds, and then sends a command to RTC 360 to collect data for us. And this is all done as part of an autonomous mission. As you can see, the integration is done. So Spot has the awareness that what the laser scanner is doing, and when it's done, it sends the command back to Spot to go to the next location. As you can see, RTC is collecting the point cloud and generating the point cloud with HD images that are used to have a colorized point cloud. When this scan is completed, the robot continues the autonomous mission to the next point. And this repeatability can be done for as many times as we desire. There is no limitation for that. Well, of course, the limitation could be the battery on the robot, which is on average 90 minutes. And this 90-minute provides us with good amount of duration to capture reality, probably once a week or once a month. It really depends on the type of project and the application that we are collecting data for. Again, the same process. Just imagine that how effective this process is when we automate it using a robot. So the next project that we use in Pomerleau is the 3D reconstruction, and for that we get the deviation from model. So in the previous slide, you saw that how the capture actually happened, and when we got the laser scan, we imposed them and align them to our beam model, and we get the deviation. This is a collaborative tool. So if we want to leave notes for our project team, we can do that. And we can also assign some issues for the project team. For this specific project, since the project was going well, we didn't have any issues, so we just played with the point cloud for the sake of this presentation. As you can see, maybe you've worked with point clouds. The number of points are huge. Maybe sometimes it goes over 100 million points for a small project. So the computer would have a hard time handling all those points. So we created a budget to stream points into the model, and we have different types of render modes for the better visualization. And as you can see, we can move around the model, and the point cloud continues streaming into the model so that we are able to use the point cloud more effectively and work with it in a better way instead of waiting for the computer to process the whole point cloud. And this application is also we can also work with different tools that we imported from our BIM model. The other application that we have and we want to use for reality capture to provide data for data-driven decision making is to have remote access to our fleet of robots. So it's our robotic command center, and it includes all our robots in Pomerleau. By this application, we have remote access to the fleet of robots, and also this includes Spot. And with this, we don't need to step on remote or dangerous sites. So if there's any site that is remote and it takes a long time to get there, we have spot there, so we can have remote access to spot for reality capture. And also for dangerous sites, we don't want to keep range with the robot while we are operating it. And in this case, we can stay out of the dangerous environment, operate the robot, and the robot can collect data for us. And by this application, we aim to teleoperate and review data in real time and capture. And this is actually happening in real time. We don't need to wait for the data to be transferred and then have a look at the data. And also, this application supports collaboration and democratization of access to our fleet of robots. So these are two screenshots of the application that we are seeing here. We have a live 360 image live viewer. So if there is any danger, we can see it live and plan to remove the danger to be in existence. And also we have different safety features for the robot for the remote access to our fleet of robots. And as you can see, in this slide, this is like a demo on how this remote access actually works. We have different sets of cameras around the robot, so we can see what's going on for dangerous environment. And if there are any obstacles or stairs, Spot is very adaptive to stairs, so we can continue to review our site conditions live with the less amount of limitations. So this is a cloud-based application that we can use it by any tool that we have. It could be a laptop, it could be a smartphone, a tablet. So there's going to be less limitation for the use of the robots on the job site. And at the end, I'd like to share our robotic vision with you. As SLAM stands for simultaneous localization and mapping, which is the pillar of the robotic applications, we'd like to leverage this technology for as-built documentation. And also, we have planned to use IoT sensors with a dynamic tool like Spot for other types of data collection. And by this, we can have a better documentation of our job site, and we also can enable augmented reality applications. And this could all take place from design to construction and to operation phases of construction project. So back to you, Robert, if you would like to share your opinion, and maybe Thomas.
I'll pass it to Tom.
Yeah, excellent presentation, guys. Really amazing stuff, and really polished, great content. We really appreciate the effort that went into this. Just want to encourage everyone in the audience, if you've got questions, off on the side, there's a panel where you can throw some questions in. I'll try to stick handle them. I guess my first question is, this is a huge investment for Pomerleau. Like, how much of this is science fiction versus reality on projects? Like, do you have Spot robots now deployed on all your projects, or is this sort of like still in the R&D phase?
I can take Sina, go ahead. You're more familiar.
Yeah, but as of now that we are speaking, Spot is shared between 4 projects in Pomerleau. So we are working on the R&D side of things and also in operation. So we actually use Spot for data capture on our sites.
Yeah, right on. So I mean, in my experience, we used to send, an operator with a piece of equipment to the job site to capture information kind of systematically. And often that was used for, different use cases for LiDAR, like usually existing building design coordination, floor flatness, and occasionally we would look at coordination issues, and very rare would we get into data collection for updating schedules for status complete, just because it was cost prohibitive. So I could definitely see this application for the autonomous robotics, but there is a huge cost threshold there. And obviously there's still an operator who has to go set up the instrument, keep it safe, I don't know, grease it or whatever's got to be done to it. How have you looked at that from an operation standpoint? Do you envision that you're going to have robots that are kind of just like, locked in cages and jump out and capture data, or how are you going to manage that fleet?
Yeah, it's an interesting question. The value again that we get from an investment like that, it's based on the different application for the data. I will say the unit is sort of like the media, the way to have the processes more efficient, and then by extracting data more often with higher quality, with in areas that we weren't able to reach before because there were confined spaces or dangerous spaces. All that brings value to the projects that justify the investment. So it seems like it's something that could see like a luxury maybe at some point, but when by sharing the actual value and by sharing the actual applications of this, I think that the investment is understood better, and just considering the safety implications and the reduction of actual personnel on site, that adds up to the getting the return on that initial investment.
Yeah, and you mentioned at the end your future vision of connecting like IoT sensors to the instrument to collect data too. Like I would imagine that's around tied into your work breakdown structure and putting like RFID tags on I guess deliveries arriving on the job site, so the robot could keep track of material, where it is and what the status is, in addition to the LiDAR data and photography data.
Yeah, definitely.
So you guys are at a very high level of sophistication here, and you've obviously built a lot of buy-in internally within the company to get this far. On these projects, like how are you achieving that corporately? How is this culture being pushed? Do you still hit resistance amongst the kind of the superintendents and the 30-40 year veterans that are kind of seeing all this technology come into the business? Like how do you build that buy-in to get access to get these new systems deployed?
Yeah, it is. It is all driven by the innovation, the open innovation culture that is led from top down. So innovation, as being mentioned before, it's one of the Pomerleau core values, and it really resonates at site level. So innovation does not for us like pushing a technology, is to really understand the project needs, like have those 40 years of experience site supers on the table discussing the value that these robotics reality capture operations could bring. And that's really how we've seen getting a more effective buy-in, because they are the one actually driving how these tools are going to be used. So it's, I think, that way of approaching projects and initiative that has made this a success.
Right on. There was a question here from Debbie regarding, I guess, registering this point cloud data against the design files or coordination files. Obviously pretty challenging with SLAM. This data that you're receiving, does it go into the Leica workflow into Cyclone, and then you do like an automatic registration, or do you have that process to get the data also like published, automated directly into Navisworks or whatever system you're using to host all this data?
Yeah, for registering the point cloud, Leica has released their cloud-based platforms called Hexagon Reality Capture. So when we capture the reality, it goes directly to the cloud, and it's automatically registered in their platform. And in terms of alignment with the model, we still use the black and white targets for the georeferencing of the point cloud, and they're imposing them onto a model.
So you're doing like a cloud-to-cloud registration, but it's automated. It sounds like and your targets are always in the same place, and the robot sort of walks the same path, I would imagine, every time. So your data set's pretty clean.
Yes, it's the exact same workflow that you mentioned. Whenever the robot is standing in front of the target, it picks it up and then starts, registering the point cloud. And we use different payloads for RTC. It is cloud-to-cloud registration.
Mm-hmm.
For BLK-ARC, it is based on SLAM. So SLAM takes care of the registration, and it's all automatic.
So Robert, just kind of going back to your presentation, which I thought was really excellent. I mean, the industrial side of our industry has always been really advanced with like workplace planning and developing like a unified work breakdown structure. And that's always kind of been a bit challenging on our side of the industry, as we've always done sort of like lump sum contracting. It's hard to get everyone organized around these concepts, right? But on these big P3 projects, you're obviously having the opportunity to step in, and there's some kickoff processes at the beginning of the project to get everyone on the same team, same side about, structuring their models and schedule and budgets with that structure. Is Pomerleau very good at that now, where every project has a unified work breakdown structure, or where would you say you are in that sort of maturity curve with getting your data properly structured?
Yeah, I would say you can be as good as you want on that end, because it really depends on the project delivery method and the team around that project. So what we do have clear is that that's our vision, and that's where we are moving forward. So we are doing it on projects like the UTSC in Ontario, and that is sort of like use case, and that is proving the value to more projects, and it's just like in the scalable point, the scalable phase. So we identify the benefits, we identify the way this can work, and now we're basically, as I say, it's not just the innovation team pushing for those discussions about common work breakdown structure. Is the actual project members, the project directors and managers who have seen the value of this, and they are now asking and leading this approach. So it is ongoing. We are aiming to have every project with that common structure, and considering that the project contract delivery methods will affect and provide some limitations on that.
And you mentioned it earlier in the presentation that you're using CostX. Is that a product that you've standardized across the business on, and is that helping to drive this process from the beginning?
It is in some regions. Again, depending on the specific needs of different teams, and every region has maybe some preference tools, but the workflow is the same, just linking and having a common data structure for these different parts, the estimation, the schedule, and the design part, and really integrate them and make everybody aware that having those links will make the data easily be connected, and it will bring value to the project, like the progress tracking, like the different ways to analyze the projects.
We had a question that came in regarding, I guess, really like how you decide where to apply this technology. Is it dependent on the size of the project? Because you must have limited resources, and you're doing so much work. Do you guys focus on certain types of projects, like pharmaceutical or data center or hospital projects where there's a lot of complexity, or are you trying to apply sort of like blanket standardization across all of your work, so you're working the same way everywhere? Like, how are you approaching that problem?
Yeah, for the digital progress tracking, we realized that it will be beneficial to have it on every kind of project. The limitations are more on the data that is available. Maybe in a residential project, we might have the opportunity to work just with the structural models, but the reason why we want to standardize it for every project is that we want to build that database, that sort of like big data for Pomerleau, where by having now these connections and by having the same work breakdown structure in every project, we can go back and extract that data from the uh, from the cloud, from the servers that host all the project's data, and then start running analysis between projects to start not only tracking in order to understand the productivities, but now use of productivities to estimate the durations on similar projects and have the data assist our teams during bidding phase. So
Yeah.
the more information we get there with more projects, the stronger, the most uh, intelligent this approach will be.
Yeah. Well, I mean, you guys are very mature on this journey, and you have a really great vision for how all this information is going to come together. And obviously, this type of data, this productivity data, is it's always been collected on the subtrade side because they need that information to manage their work, essentially, to understand their productivity rates. But GCs, typically are kind of doing sort of like data collection in the field, counting manpower and kind of keeping track of it. But your vision here is obviously to start to automate the collection of that data. But just going back to like your source information that you're extracting from the project, it sounds like it's mostly coming from Procore. So I would imagine that's coming from like daily site super reports on sort of counting hard hats, right? Or are you exploring other more automated ways of collecting data on the amount of labor that's present on the job site and correlating that against different trades?
Yeah, we're exploring those automated ways, the two ways of approaching innovation, where, as I mentioned, we have some mature technologies and already available solutions like, the Procore man tracking log. That's a way to do things, but in order to achieve automation, we need to explore the emerging technologies, the IoT sensors, the cameras with image computer vision that can automate the tracking of manpower by different trades and contractors. That's also something that we have now in our workflow for emerging technologies.
Excellent. Last question about the robot. How has the reaction been on the job site when you introduce a robot that's going to walk around the job site? How have people on the job site reacted to seeing that on the job site? Are they okay with it? Are they scared of it? Are you worried about vandalism? Like, what's been the reaction so far?
Well, the reaction that we got is, I would say, is pretty good because they see a cool robot going around and collecting data. The first thing they ask is, what does this robot do? So we take time to explain them this is the robot for the reality capture, for data collection and different types of data that we collect. And after some time, they just get used to it. So it's going to be a part of the crew of a job site. So the robot is moving around and takes care of the job that is assigned to, and then goes back to the location that it's supposed to be.
Have you asked, have any of the subtrades or suppliers that work for Pomerleau asked for the data stream to use for their own purposes?
So far, they haven't asked for that. We are using the data for ourselves, but we are open to, we have a data sharing culture, like Robert said. So if we receive interest and needs, we are open to discuss it.